The natural sciences make up everyday life. From physics to chemistry, biology to environmental sciences, everything is in some way encompassed. Since science is specifically defined as the intellectual and practical activity encompassing the study of the physical and natural world through observation and experiment, using this definition, you practice science every time you note the color or scent of an object.
Next is Mrs. Ferguson, an environmental science teacher at Fishers High School.
What are a few key discoveries that aided in the development of environmental sciences?
I think a big thing, it wouldn't necessarily be discoveries, but I would think like movements would be a huge thing. Mm-hmm. So with like Rachel Carson in Silent Spring and starting this whole idea of the global impact because of pesticides having unintended consequences that affected the world. I also think you have things like the Cuyahoga River that have been like oil all over it and Minamata disease in Japan and all those little events that have added up to this fact that our environment is damaged beyond the point we can help. So I think it's a lot of movements that have added up and a lot of huge crises, like environmental crises that people see. And the more we're all linked in social media and the more that we're all linked with what's happening around the world, the more we can see everything.
So how do doing hands-on activities help further the understanding and knowledge of this science?
Well, it just depends on what we're studying. So if we're doing soil, I think it's important to understand soil analysis and how to do those testings. Or if we're doing pollution, we just did an acid rain lab or a sling cycrometer, relative humidity, and we linked relative humidity of buildings related to how kids get asthma and stuff like that if it's a higher number. So it's those type of things that it's not one of those things you might use this one day. Everything we learn in this class is what we will use. It makes you a smarter individual and a more aware individual of what's happening in the world around us.
Okay, one more question. How does imagination play a role in the area of your science?
Well, I think you have to be a very imaginative person to figure out how to fix climate change and how to fix big world problems. When we think of huge people that are doing this, it's like Elon Musk, right? And these type of people that are saying here is the we have this much carbon dioxide, how do we get rid of it? And it's thinking beyond, let's not use fossil fuels and stuff like that, let's use all these other different types of sources. And I think that's if the world's going to get saved because of climate change, it's going to be thinkers that can do that type of thing.
And up next we have Mr. Mock, a Fishers High School teacher who has been teaching AP Physics 1, 2, and C for the past few years. We then asked him a couple questions about the natural sciences. What are a few key discoveries that aided in the development of physics?
If I tried to say anything the first thing is the idea of measurements, I think is important. So once we figured out lathe time and started using that, that's important. But that's not going to show up in any history books because we don't really actually know the dates of it. But I think that's important because then suddenly people started thinking irrigation, water, volume, area to grow crops, taxes, area. So the quantification of what I call measurements, which means we got Z-meter stick, and it's important, and I cover it because it's important. Without this, a lot of things, would be different. The second one I would say is pretty important is we are not the center of the universe. So the whole flat Earth thing, I'm gonna roll my eyeballs on that.
Craven's gonna watch this.
It's important to understand that we are just a part of a cog of everything. So I think that was probably the two biggies at the moment. And then the third one would be quantum mechanics, the fact that things get strange when it gets small. And that kind of puts us on what I call the path that says we don't know as much as we think about the universe. So from that standpoint, I think those three are pretty important.
All right, so question number 2 is, when can you consider something to be a fact rather than a theory or hypothesis? Is law a fact?
I look at a law as just something we haven't disproved yet. I am very uncomfortable about stating a law that, how do you say, it hasn't been withstood the test of time. I'm really convinced that a lot of our laws may actually be improved not to be as accurately as we think. So I don't like the word law. I think we actually know less about everything we think we know than is actually out there.
So another question is, how do scientists all over the world effectively communicate new findings and ideas?
Poorly. It's a beef of mine that failures are never communicated well. People are very embarrassed about the idea that I did something and we found nothing. So I think there's a whole body of knowledge out there that we repeat the same mistakes multiple times because we're so afraid as a society of failures. But you think about it, I mean, think of the bridge in Miami. It fell. We need to investigate why it failed and figure out why it did not do it again. So, I mean, when you look at publications, they publish things that work. Articles that show success are published. The stuff that doesn't work never even gets written up. They go, oh, we're embarrassed, and we move on. I think there's actually knowledge for what didn't work. I mean, so I think we're poorly about it. We communicate the successes, and that's about it. And sometimes it's one-upmanship.
The next one is, where is your area of science used in the real world apart from teaching?
Little bits and everywhere. Like I'm biased, and then everything eventually turns down to physics. So when I was in high school, you majored in biology, chemistry, and physics. They didn't mix. Nowadays, if you want to do biological research, you're dealing with the physics of cell walls, cell membranes, how they work together. And I use the word the devil's in the details, which ends up being physics, even though I didn't major in it. So I think everywhere.
Okay.
I mean, I'm biased, but there's not a person who can't argue, except a math person.
So for the final question, we have these things called ways of knowing,
Okay.
knowledge. And so they're like how you can know things to be. And one of them is imagination. And we were wondering what you would say, what role imagination would have in physics.
Okay. Mixed feelings on this. If you say you can't do something, that limits and boxes you to a path or blocks avenues of exploration from you. So saying something is impossible, like in my case, you can't go faster than the speed of light, I think has a tendency to limit. So the imagination that says maybe we can go faster than the speed of light, I think would open up some ideas that might lead. Obviously, imagining things is not necessarily all that good, but the other thing to do is we use analogies. Like I will unfortunately say the flow of electricity is like the flow of water. That has its advantage on a basic level to get people to understand things. But I also think that those analogies sometimes lock us down a path that says I'm going to treat electricity as water when it is not. And it works on some scenarios, but eventually if you consider it as water, you're going to get the wrong answers and limit the ability to go into what electricity can really do. So I'm a mixed bag on that. I really do. There's a role of it, but there's also the role of it can actually lead you down a path that blocks avenues of exploration. And that's one of the things I just be concerned about. Be careful of what you ignore or say can't be done, because then it limits possible solutions that are out of the box and different.
Thank you for watching. This was our presentation on natural sciences. I hope everyone has a good day. Goodbye.